Hiker Brainbox. Welcome to Brainbox YouTube channel. In this video, we will break down motion problems and identify key strategies in solving them. Before you continue, don't forget to hit like, subscribe, and click the notification bell to keep you posted on more review topics. You can also avail of our CSE books and other reviewers. Just click the link to our shop in the caption below. With motion problems, there are three primary quantities: speed, distance, and time. These three are related based on the following equation: speed is equal to distance over time. In other words, speed can be computed by dividing the distance traveled by the time it took to travel that distance. There are a total of three possible expressions of the relationship between speed, distance, and time. It should be noted that these three equations are all equivalent and can be derived from each other. Let's try some examples to get accustomed to common motion-related problems. Alice wants to go to the neighboring town 40 kilometers away to buy an air fryer. If she bikes at 20 kilometers per hour, how long is the round trip? Using the formula, to get the time, we have to divide the distance by the speed. We can then substitute the values given in the problem. Take note that the question asks for the duration of the round trip, which means the distance traveled has to be multiplied by 2 first. Solving for time, we divide 80 kilometers by 20 kilometers per hour, giving us our final answer, 4 hours. Let's look at another sample problem, with a different twist this time. Two out-of-control trains are hurtling towards each other on a train track. At the moment, they are 225 kilometers away from each other. If the first train is traveling at 60 kilometers per hour and the two trains are projected to collide in 3 hours, how fast is the second train moving? In this problem, the distance to be covered is 225 kilometers, but in this case, we have two moving entities, with each train having its own speed. Since they are moving towards each other, this means that their speed is combined in traveling the 225 kilometer distance between them. Setting up our equation, we use the speed equals distance over time form. Substituting for the given values while noting that the speed of the two trains combines, we have the equation 60 plus x equals 225 divided by 3. Solving for x, we can see that x equals 15. Therefore, the speed of the second train is 15 kilometers per hour. To test your understanding of this topic, answer the following exercises regarding motion. You have 1 minute to answer each item. Good luck! Number 1. You have to fly to a meeting in 3 hours in a city 1,500 kilometers away. How fast does your plane have to go so you can make it in time? Timer starts now. Time is up. The correct answer is 500 kilometers per hour. Using the equation speed equals distance over time, we divide 1,500 kilometers by 3 hours to get our required speed, 500 kilometers per hour. Therefore, The plane has to travel at 500 kilometers per hour. Number 2. Alice and Bob accidentally ride different buses traveling in opposite directions. If Alice's bus is traveling at 55 km per hour and Bob's bus is traveling at 45 km per hour, how far away are Alice and Bob from each other 3 hours into their trip? Timer starts now. Time is up. The correct answer is 300 kilometers. For this problem, the speed of Alice and Bob's respective buses will combine in terms of the distance in between them. Therefore, with the speed expressed as 45 plus 55, we substitute these values into the equation shown here. Solving for distance, we finally arrive at the final answer. After 3 hours, Alice and Bob are 300 kilometers away from each other. Number 3. A motorcycle rider is racing against a car. If the motorcycle is traveling at 70 km per hour while the car travels at 60 km per hour, how long will it be until they are 5 kilometers away from each other? Timer starts now. Time is up. The correct answer is 0.5 hours. In this particular instance, the distance between the two vehicles is described by the difference in their speeds. Therefore, the speed we will be using for this problem is actually 70 minus 60. Substituting these quantities into our equation, we get a value of 0.5 for our time. This means that the car and motorcycle will have a gap of 5 kilometers 30 minutes after the race begins. That's a wrap. Share this video for others to learn too. If you want to learn more, you can avail of our CSE books and other reviewers. Just click the link to our shop in the caption below. If you are new to this channel, don't forget to like and subscribe. Thank you for watching.